Hi, I'm Tapash B from Wizert. I teach physics and mathematics. Today, I'll show you one application of principle of conservation of linear momentum. What is principle of conservation of linear momentum? As you see in the written on the board, the total momentum of an isolated system remains conserved. Now, what does momentum of a body means? We know momentum, by momentum of a body, we mean that momentum, if we denote it by P, then P is equal to m times V, where the P is the momentum of the body, m is the mass of the body, and V is the velocity of the body. As velocity is a vector quantity, so on the other side, P is also the vector quantity. Now, according to the principle of conservation of linear momentum, or simply according to the principle of conservation of momentum, we see the total momentum of an isolated system remains conserved. Now, what is an isolated system? An isolated system is a system of bodies, means the simplest system means a system that contains two bodies, or it may contain three bodies or four or any number of bodies. And it is isolated. That implies that there is no force on the system from outside. That means if there is any force acting on one body, that is applied by some other member of the same system, not from the outside. So this is one isolated system of bodies. Then, according to this principle, the total momentum cannot change. They can collide, they can push each other, so they can experience force from each other, but they cannot change the total momentum. Individual momentum may change. Now, we are using one problem, as one sample problem, as one example to understand this principle. Okay, so see what the problem is. It is displayed on the board. You see that in this problem, there are two bodies. And what does it say? That a body of mass 3 kg moving toward east at 200 meters per second hits another body of mass 5 kg at rest. After the collision, two bodies stick together. Find the velocity of the combined body. So this is a system of two bodies, and there is a collision, and applying the principle of conservation of linear momentum, we will find out the velocity after collision. And here the bodies combine in the process of collision, and this kind of case, that is where after collision the bodies combine, we call it inelastic collision. In case of elastic collision, they are separated, and it is a case of inelastic collision. So, okay. So to solve the problem, first we organize the problem. So what we do, we first take that the momentum before the collision. Okay, what is happening first? Let us see that. Okay, there is a body at rest. So we are first trying to understand the case that is happening before the collision. So this is what is happening before. Okay. So what is there? There is a body. We are calling it the second body, that is mass of which is 5 kg, that is at rest, and the body is at rest. Sorry. And another body that is moving towards it, its mass, we are calling it M1, and this M1 is 3 kg. So the 3 kg body is moving. Now, the initial speed of the first body, or the initial velocity, we are calling it U1. The U1 is given, that the value of U1 is 200 meters per second, and it is moving towards east, and we are consider our axis along which, that means they are moving, is extending from west to east. So we are taking this eastward direction as positive. And okay, what is the velocity of the second body before the collision? It is 0, because it is given that is at rest. So this is the situation immediately before the collision. Okay, so let us see what is happening after the collision. After the collision, okay, so we get it after. So we see that after the collision has occurred already. So two bodies are combined now. So the mass of the body is a combined mass, that is m1 plus m2. And you understand the total mass is becoming 3 plus 8, 5, that is 8 kg is becoming the mass of the body. And the body is moving at velocity v. And this v is unknown. That means we don't know this velocity, and we want to find out this velocity as the unknown quantity. So this is we have organized the problem. Now, how do we solve it? So we are now applying the principle of conservation of linear momentum, which says that momentum doesn't change. That means momentum finally is same as the momentum initial. Initial momentum and final momentum are same. So use the symbol PF for the final momentum, that is the momentum after the collision, and PI, the momentum that is there before the collision. Okay, so that means PI is same as PF or PF is same as PI, but I have taken PF first just to organize the problem in a convenient way. Now see, what is the momentum after the collision? Okay, its mass is m1 plus m2, and we know the momentum means mass times velocity. So m1 plus m2 times the v, final velocity. So this is the momentum before collision, and the momentum after collision is becoming, just a minute, we don't need the parenthesis here. So we remove this. So, okay, so momentum, initial momentum is the momentum, sum of the momentum of two bodies. So it is becoming the sum of the momentum of first body and the momentum of the second body. So that means it is m1 u1 plus the m2 u2. So you understand that m2 u2 is the mass of the second momentum of the second body, that is mass times the velocity, and m1 u1 is the momentum of the first body. That means in the same way, mass times the velocity. So we now okay, so we should go down a little bit now. Okay, so okay, so we are at the end of the page. So let us go to the next page. And but remember that we have what we have got here. So in the next page, when you go, we again, okay, I'm writing what we got there. That is okay, we got m1 plus m2 times v is same as m1 u1 plus m2 u2. So we are finding out v, which is becoming equal to the whole thing, that is m1 u1 plus m2 and u2, and divided by m1 plus m2. That means sum of the two masses are in the denominator. And here we now plug in the values, and you know m1 is 3 kg. So I am writing the value of m1, and then I'm writing the value of u1, which is 200 meter per second. So this, and plus this quantity is becoming 0, because you know u2 is 0, that is the body at rest, its momentum is also 0. So, and in the new denominator, m1 plus m2 means mass of the total mass of the two bodies, so that is 8 kg. Now you can check the unit wise, that kg and kg, we can cancel them. So if we simplify, we get 75 as the value. We can check it. So it is 75, and the unit is remaining meter per second. And C, it is a positive quantity. That means it is similar in sign to u1. And you know, u1, the initial velocity of the body was 200 meter per second, and that was towards what direction? That was towards east. So here the positive quantity indicates that this velocity is also towards east. So we have got the velocity, final velocity of the combined body, and that is moving at 75 meter per second. And as it is 75 meter per second, that means it is remaining positive. Then we can say this is also a motion towards east. If we would get negative, which we haven't got here, we could say that the motion is towards the west direction. It is, note that it is it is a problem of one-dimensional case. That means all the bodies are moving, or whatever we are getting, along one straight line only. We can solve a more complicated problem where two-dimensional or three-dimensional motions are there, and but this example covers just once as one covers the application of principle of conservation of momentum in one dimension. So solving this problem, we have got the final answer. You see that the final velocity is 75 meters per second east. Thank you for watching. Bye.